Welcome everybody to our webinar today. I'm glad you were able to attend, and hopefully this will be a beneficial time spent for you to learn more about opportunities for automation in a microbial testing laboratory. So to start off our discussion, just spend a little bit of time talking about microbial safety principles. And the idea here falls in line with the approach that's been taken in most industries now of addressing any kind of risk that comes from microbial contamination, whether that be in foods through FSMA guidelines and HARPC plans, or through USDA and HACCP plans, or in pharmaceuticals through ICH guidelines. All kind of work off of this same concept of identifying the risk that your product is susceptible to, then identifying a preventative control for that risk, measures that can be taken to try and to control it and minimize it. And then there has to be a monitoring tool to track that preventative control to make sure that it's being implemented the way that it should, and that it's actually doing what it's supposed to. So those are the key elements of this risk-based approach to microbial safety. And when we talk about microbial safety, there's really two main areas of concern. One is contamination, where the organisms are presented or introduced onto a product in high enough levels to then cause an infection. And the other is through microbial growth, where there may be a small amount of the organism present, but conditions are right for it to grow and reproduce so that it can grow and reproduce to high enough numbers to cause an infection. And so when we talk about preventative controls for these two main concerns, in terms of contamination, the main preventative control is to apply a kill step, as well as keeping facilities clean and doing the necessary sanitation. But the main way of doing that, or eliminating those organisms, is through some sort of a sterilization or kill step, often done through heat, maybe a combination of heat and pressure, and other up-and-coming techniques for being able to implement that sterilization or that kill step. On the microbial growth side, to prevent growth, the preventative controls there include the common hurdle technologies, the hurdles that can get in the way of growth, mainly reducing water activity. And if you have joined in any of our other webinars, we had a previous one where we talked about techniques to prevent microbial growth and the importance of water activity. So that's available in a previous webinar. Of course, this time we're going to talk more about the contamination control. And so in terms of monitoring each of those individual potential risks, the monitoring for microbial contamination comes through microbial challenge testing, basically testing the product to see if there are organisms there. On the hurdle technology and water activity side, the monitoring happens through, of course, water activity testing. So in terms of solutions that can be provided by Neutec Group, Neutec Group can provide solutions in both of these realms, whether you're talking about the monitoring done through microbial challenge testing or microbial testing, or you're talking about the monitoring done through water activity testing. Neutec provides a line of water activity instruments that we've again discussed in previous webinars, but they also provide automation for the microbial lab, anywhere from media preparation and plating to automated dilution and mixing, through inoculation and colony counting. So if we take a look at kind of what that workflow looks like in terms of the solutions that are provided by Neutec Group, when we look at the microbiology lab workflow, essentially there's just two parallel lines that are in operation, and they intermingle and rely on each other. But that first line is, of course, media prep or buffer preparation, where the materials are being prepared either to combine with the sample or to prepare the media for the growth that's going to happen. And we provide solutions throughout that entire process, and we'll discuss each of those in what we would call a media kitchen. And then on the other side, you have where you're taking your sample and you need to inoculate it onto that media to see if what grows there and how much is there. And so that process, we provide solutions as well, everywhere from dilution or initial dilution through inoculation and colony counting. And then, of course, we offer additional solutions to meet the requirements for analysis. You can see the water activity instruments there that we talked about previously, some other tools as well. Wanted to put this in front of you so you know the depth of which solutions, the depth of solutions that Neutec can provide for anything that you may be interested in. But now let's focus in on microlabs. So of course, there's the requirement of being able to do this testing to look for the evidence of microorganisms. How in what quantity are they present? Is it high enough to be dangerous and cause an infection? And the traditional or manual ways of doing these types of tests have been around for years. But they tend to be fairly laborious, time-consuming. You need some effective training to be able to do it well. And so there's a lot of challenges associated with trying to manage and run a microbial testing laboratory. There's the process of sample prep and setting up and doing your dilutions and making sure you're doing those correctly and weighing things correctly and mixing the right way. And then you have you got to make your media. So how do you fill those petri dishes? And you've got hot agar running around the laboratory, and is it being poured correctly? And then at inoculation, are you preventing cross-contamination using good practices to make sure you're not bringing in organisms that aren't supposed to be there? And then once you've got the inoculation and you've grown it, how do you count it? Is that a manual thing? And trying to do counts all day long gets very tedious, can lead to mistakes because you're looking at the same thing again and again. And then how's that data recorded and how's it managed? So a lot of challenges associated with this process, and certainly it would be welcome to have some solutions to help with that process. And so if we take a look at the solutions that are provided for just kind of an overview, a 30,000 foot overview, Neutec offers solutions for every one of those steps, from sample prep and doing the dilutions and mixings to media prep, sterilization of media, petri dish filling, inoculation, and count all the way down to counting. Are solutions that are there and are readily available. And so there's a lot of questions also that you might consider when you're thinking about these going to these automations, and are they going to be useful, and are they appropriate for your situation? And so these can be a lot of different things to consider, anywhere from where are you filling these dishes? Are you having to overcome obstacles to be able to do it? Is there a lot of chance of spilling and contamination in the lab that could all be avoided if you were to be able to use automation? So let's talk about each of these sections individually. First of all, we'll talk about sort of the media kitchen or media preparation and filling. And the solutions that are provided by Neutec are made in cooperation with our partner, a Swiss company called BioTool. They're the ones that manufacture this equipment, and we partner with them as a distributor for their equipment in the U.S. And they have many years of experience, 20 plus years working with agar preparation and fillers. They've really worked hard to try and make equipment that's safe but very, very efficient. So as we talk about this idea of media prep, over the past years, there's been somewhat of a trend to try and sort of simplify this process by going to where you can buy these media that have been pre-poured. So you can buy them like a consumable, these ready-made plates, and then use them and do your inoculation, and it saves you this process of having to create your own media. But there's some challenges associated with that, to the point where there's sort of been a reverse in that trend to go back to making plates in-house because of all the challenges that are presented by using these ready-made plates, whether that's costs, availability, where you start to see potential interruptions in supply chains, and there's maybe you can't get those media when you need them. Shelf life is, of course, a consideration. It's not, these have a limited shelf life, so you can't stock huge numbers of them in inventory and then just use them when you need them. You have to be able to, when you acquire them, you need to be used fairly quickly. And then it kind of makes it difficult to do any kind of specialty plates where you might want to do selective media to look for special organisms, or different types of media that you might want to use. And so this idea, though, of bringing it in-house does present itself with some problems as well, because when you bring that in-house, the process of filling these petri dishes can become tedious. It's a repetitive activity that, and whenever that happens, there's always a chance for mistakes as you start to do things over and over again, and you kind of lose focus. And so creating these media kitchens, and when trying to do it manually, can become a bottleneck for the labs, where you're trying to wait for media because it's just such a tedious and long process. And that's what's fighting back against the idea of leaving these ready-made plates and going to trying to produce that in-house. So there's those advantages, but there are those disadvantages of having to overcome these obstacles to be able to start producing your own media in-house. A solution for that then is to go to some automation. And so in terms of automation in that process, Neutec provides, in cooperation with BioTool, media preparators so that you can prepare the media itself. This saves huge amounts of time because it eliminates the need to handle a lot of bottles and try to clean them and autoclave them. It all is taken care of in one unit. Neutec provides a huge selection of agar media and filler units suitable for any budget or capacity. And we also, through BioTool, provide an XY tube and bottle filler that's just a really neat instrument when you need to fill all kinds of different sizes of tubes. So we're going to talk about each of these individually. So first of all, in terms of media preparation, we have a couple of models. The model that's the right one depends on how much media you're going to prepare. So they're called Profoclaves, and we have the PC10, the PC20, and these are multi-purpose sterilizers. They're very good as far as the fact that they have the ability to stir. They have a fully controlled internal stirrer, so you don't have to go in there and stir it. It's all done automatically. They have an efficient cooling system, so it shortens the cooling process, so that you don't have to extend the test time for so long. And in this case, the media itself is actually measured. The temperature is measured with a temperature probe, and so everything's controlled on the media's temperature rather than the temperature of the instrument itself. So it gets a lot tighter control over the temperature of the media, and more effective at sterilization and processing. It also includes a delayed start, so you can set this up to start first thing in the morning, and then be able to, when you come in, you're ready to go and start moving forward with pouring media into plates. In addition, these systems are set up so that they can be connected directly to the media fillers that we're going to talk about, so that you can have an uninterrupted continuous operation, again, eliminating the potential for contamination by having to remove that media. It can just be set up to go in a true media kitchen fashion of a continuous process to go straight into the automated media fillers that I'm going to talk about. So, of course, the advantage of having one of these media preparator systems over sort of the traditional way of filling media in flasks and then putting them inside of an autoclave. Of course, you're not the biggest advantage is you're not dealing with all of these individual flasks or bottles, any of which have the potential to be dropped and broken. They're hot. They have to be handled carefully. And just in terms of the amount of media or material that you can put in there at the same time is limited by the space that's being taken up. And so in terms of advantage over having to use a large autoclave, these media preparators, that's their purpose, is to make media. So they're really effective at doing that. And again, as we talked about, can be hooked up for a continuous operation. And of course, it also eliminates the chances of overcooking the agar by not watching it or keeping it in the right amount of time, but also avoids all the cleaning that could potentially come from utilizing all those different flasks. They all have to be cleaned. And so there's a lot of time savings associated with being able to go to a media preparator. Now, if you do need to do autoclaving, we do offer solutions for that as well. And so especially if you need to autoclave things that other than just necessarily media, there may be a lot of things that you need to be able to autoclave. And so we provide effective alternatives to traditional autoclaves through the PrioClave line of instruments. The nice thing about these systems, they use a round chamber instead of a traditional rectangular chamber that you typically would see. And that's really important, actually. It provides them with a very high level of efficiency. And so because of that, so they don't need to have they don't need external steam generation. They don't need redundant chamber reinforcements, steam jackets. Because all that's eliminated through this design, the price point on these is typically 25% lower than what you would pay normally for an autoclave this size. Not only that, but it reduces operating costs because it doesn't require as much energy input, nor does it require as much water use. So it's really environmentally friendly. It improves the greenness of your processing because of this. There's not such a need to utilize so much water in the process itself. So some good solutions there for situations where you do need an autoclave. Now, in terms of automated dish filling, basically the idea here is how many dishes are you going to make? How many dishes per batch, per day, and per week? How many different types of agar? How many liters of agar do you need to prepare, or can you prepare to then put in to plates? And so based on those considerations, there's essentially a system that's suited for whatever size operation you may have, anywhere from very small. So here we're talking about less than 100 dishes per day. Then we offer what's called the Dosi pump, where it basically is a single plate filler, but you control that through a pump and through a setting that distributes the exact same amount of media every time. So the nice thing about that is that there's no pouring of flasks or handling of flasks. Instead, you can, again, directly connect that up if you want, or the media can come from any kind of a container. And then you just control the flow into the dish, and you can run those one at a time. So eliminates mistakes, but again, not high throughput. If you're up to about 200 to maybe 1,000 dishes per day, so a little bit smaller operation, then the best choice would be our intermediate, the PS20. As you move up to higher amounts, we have additional options, the PS200 for a carousel approach, and then to the really high amounts, even up to 15,000 dishes per day if you're operating on multiple shifts. Then you go to the PS900 system, and I'm going to talk about each of these systems now individually. So we start off with the PS20 or the Petri Swiss 20. This fills a set of 20 plates automatically. Now the system does have to have the plates fed to it, so this isn't truly a load and go or walk away kind of a system, but it does automate the whole process, so it eliminates, again, those opportunities for contamination. And if you're only running maybe 20 plates, for instance, then this is a great option to get those done very quickly and with very high levels of accuracy. So this is really ideal for, again, a smaller operation, maybe an academic lab where you don't need a huge number of dishes, and you may not be producing dishes every day, but you want that advantage of being able to assure the correct distribution of the media and eliminate some of the labor involved. Really nice thing about this system, the finished plates are loaded automatically into this Petri rack. You can take those out continuously if you want, but you can also leave them in there. And essentially at the end, you'll have a stack of 20 Petri dishes. That rack can be removed and the dishes kept in it, and that rack can be transported and chilled, or you can put it in and it can be even incubated. So there's some advantages in this system as a full work flow in terms of not having to handle those plates and worry about dropping them or something happening to them by keeping them secured in the Petri rack. Now, on all of the Petri Swiss autofillers that we're going to talk about, one thing that they all have in common is the use of a double-headed pump. And you can see that shown on the front of the image that you're seeing. That double-headed pump is actually quite important because what it allows for is a smooth delivery. So one thing that you don't have problems with any of these Petri Swiss options is bubbles, getting bubbles in the media, which can cause a lot of problems. This double-headed pump delivers that media quickly, but in a very smooth way to avoid any chances for having those troubles with air bubbles forming in the media. The next size is the Petri Swiss 200. This is a carousel-based approach. Platform capacity of 180 plates per turn. The nice thing about this system that you won't find with other traditional carousel-based media fillers is that the racks in this carousel can each individually be removed. And the reason why that's important is that it makes it into more of a continuous system. There's no pauses, there's no interruptions where you have to basically remove the entire carousel and get those Petri dishes out. Any one of these racks can be added or removed at any time. So once a rack's done, it can be removed, the plates can be taken off, and empty plates put back in and then placed back in the carousel, so that you can, it allows you to then be able to essentially have a continuous flow. Just a little bit of work that needs to be done to take those carousels out. But you can, this is really a day-long, real production, no waiting, continuous creation of media plates. And again, this system, as with all of them, can be hooked directly up to the media preparators, and it uses that double-headed pump. This system can be done, your throughput is about 4,000 dishes per day on an 8-hour shift. Very efficient method for filling these Petri dishes. But in terms of comparison, the PS900 is a linear-based approach rather than a carousel. And the carousel is maybe a more well-known process for doing this auto media fill. But in reality, this linear approach has a lot of advantages over the traditional carousel. And that's one of the reasons why BioTool developed it is as a solution for some of the challenges that are associated with that carousel approach. So again, here we've got day-long production, no waiting time for agar solidification or for to take the dishes out. The dishes are automatically taken through the process and then placed on a rack in predefined stacks that can be then taken away at any point where you can add space on if you want to keep those plates all together. They'll just basically stack themselves in lines, ready for you to take and even put onto a cart if you want to design it that way. Here we're more in the 5,000 dishes per day in an 8-hour shift, but if you then do that throughout a 3-day shift, then of course you can get up to 15,000 dishes poured per day. Platform has a capacity of 400 plates, but it can be reloaded at any time during filling and as well as taking the plates off at any point after filling. So really efficient way of being able to do media filling. It's faster than the carousel, as well as being more hands-off because there's no loading of racks here. You simply place the petri dishes on the loading platform, and any size stack you want, you can put them on at any point, and the system just takes those in and automatically puts them through the process. Now, one of the things that's been maybe a concern for this linear approach is just the size. It does have a sizable footprint, and depending on how many dishes you want to do at a time, that can increase if you're going to leave them there after they've been filled. But in reality, if you compare to a traditional carousel approach, the number of plates, if you're going to take them out of the carousel, at some point they have to be taken out. They're really going to fill up the pretty much the same space. So you're still going to need that footprint, even if you're going to use a carousel approach. So in terms of comparison that way, there's really not a lot of difference. And because the PS900 is modular, it can have added space easily put there, or it can be set up to go automatically onto a rack or a movable tray that could then be used to transport those plates. So there are options for being able to really optimize the use. Now, in terms of comparisons to of the BioTool large filler units to the traditional carousel approach, there's some big advantages here for not only for the carousel that BioTool produces, but also even more so for the linear approach that we just described. Both these systems, in comparison to older systems, are designed to be ergonomic and safe. There's no, again, removing of racks, trying to get them out of the individual slots while the carousel's running. You just basically take that entire rack out so that you're not putting yourself in any kind of danger. They're set up so that they don't require you to be really tall to work, or you have to use a stool. So in terms of safety, that's really important when you start getting into these micro labs where there's a lot of potential for problems when you're trying to reach up really high to access some of these types of carousel systems. So that's just a few of them, but just in terms of throughput, just a huge advantage to the linear because it truly is continuous. Those racks can be filled at any point. So when you do a comparison between the linear approach with the PS900, that's the red line, and compare it to both the PS200 carousel approach and then to the standard carousel, traditional carousel approach, you can see that by far in the same amount of time, the PS900 can produce a larger number of dishes than the other two systems. And mainly that's because there's just no interruptions with the PS900. And especially with the older traditional carousel where you've got to do it as a one-time, a process of removing all those plates at the same time, then you're going to have downtime. And that's where the curve flattens, and then it starts up again, and then it flattens. And because of those interruptions, the linear approach will always be faster and more efficient. Now I want to show just a quick video of the system in action. I think we all like to see those things visually and watch them work. And so we'll spend a little time here just to watch a quick video. So what you're going to see again is the PS900 linear approach, a fairly off-the-shelf, obviously, system, not terribly difficult to get set up. And there you see that two-headed pump that we've talked about that eliminates the bubbles. And here it is in action. So you put the petri dishes on the loading platform, Again, any stack, it doesn't matter the numbers. The final stacks are going to be dictated by how you program it and how you set that up. And then each dish is brought in and filled with the media. Again, that media can be coming from several different sources, including the media preparator that we saw earlier. When this media is being filled, it's done under UV light so that it keeps the chamber sterile, so you're not having issues with whether or not the filling process is avoiding contamination, and it's keeping the media safe and sterile and ready for use. Once the media is filled, the system then transports the plates and then puts them and stacks them in, again, predefined heights. So you tell it how many high you want that stack to be, and then it automatically removes them out and puts them into a line that will continue to grow based upon how many of the plates you're going to run in a certain batch. So in terms of use, this is a fairly simple process, very nice, very automated, fairly easy to set up and program and get up and running, but just has a huge efficiency for being able to produce media. Now, sometimes you need to fill things other than just petri dishes, and the PS line of media fillers does a great job of filling petri dishes. But what if you need to fill test tubes, or you need to fill bottles, or you need to fill different sizes of petri dishes? Then there's an additional solution, again provided by BioTool, with the XY tube and bottle filler. And so this system allows for the free positioning of any rack and any tube or any kind of container. It's a fairly intuitive program to program it to where those things are located. You basically use an interface to describe to it where things are located and how many, and then it automatically goes and finds them. You tell it how much to dose or how much to put in, and it puts in that same amount every time. So you eliminate any kinds of mistakes. So this is a true walk away. You can program this, and as long as your solutions or whatever you're going to put in is supplied, you can set it up, walk away, come back, and all of your containers are filled. And it doesn't necessarily about doing this any faster than, say, a human could do it. The fact that the advantage is that there's not somebody there doing it. It's set up, and that person's over doing something else that's critically important, rather than spending time trying to fill containers. And so that's a huge advantage of this system. And it can do everything, again, from a 96 shallow well plate up to very tall tubes. It's just a matter of telling it where it is and how to find it. And so there's several different choices in terms of racks. You can have variable positioning grids. So you can basically tell and establish on the system a grid system that you can manipulate or change depending on the size. You can have fixed frames if you're going to use the same thing over and over again. And then there's also some custom templates that are already loaded that you can use depending on if it's something that's a frequently used application. So I want to show you a real quick video of this as well. As I've said, we've had some really great results with this system, a lot of interest for anybody who has to try and fill up all kinds of different containers for doing clinical studies or doing investigations. And even if you got to fill tubes up prior to doing your other microbial work, this is a great way of being able to do that. So the idea there is that you can fill a petri dish or a test tube. It has a laser that guides where it is, so you always know where it's going to fill, and you have a precise ability to program it to make sure that it's that it's always filling the right bottle and filling it with the correct amount. Again, using the same double-headed pump approach that the other systems use to avoid the formation of lots of bubbles. Easy to clean up, easy to use. It's a great solution for anyone who needs to do a lot of tube filling. So now I want to move away from the media preparation and talk a little bit about the actual sample prep and inoculation steps. And and the counting of colonies, sort of the other half of the microbial lab. So in doing that, we partner with IUL, a Spanish company that has 30 plus years of experience working in this realm in inoculation, automation, and colony counting. So they do a great job and really have some nice solutions. And we'll talk about those each individually. So now we've moved on to our second line in terms of our workflow. Rather than the media prep, we're now talking about the inoculation process and handling of the samples. One of the first steps that has to be done in a lot of cases is a dilution step on the sample itself. And so we provide a smart diluter system. Again, supplied through IUL. This system is gravimetric, so it's basically doing things by weight. So you set it up with a bag that you can fill with some type of a buffer or a diluent, and then your sample, and then basically you tell it what kind of dilution you want to achieve, and the system automatically creates that dilution based upon weight and concentration from those weights. And so it's a very nice system to avoid mistakes that can happen when you start trying to think about dilutions and what have you done, what have you put where. The smart diluter can eliminate the problems and challenges that can come from that. We also provide lab blenders that can be used to, again, mix the sample once that process has begun and the dilution has been made. And so these are really nice systems for doing the mixing. Sometimes they're referred to as stomachers. Actually, that's a name of an actual type, but as in general, they're sometimes referred to that. And so these masticators are essentially the same thing. Some of them have timers, variable speeds. You can has a window on it so you can see what's happening as well. So that's for the sample prep. Next is the next step would then be inoculation, and the process that an approach that IUL provides is called spiral plating, and the spiral inoculation. And the really nice thing about this approach, and it's a mathematically proven method, but what it does is a threefold dilution on a single plate. So this drastically reduces how many plates and augers you have to use. It reduces inoculation time. It reduces incubation space because you're not having to put so many plates in there. And it also reduces the time required for colony counting on a whole plate. Whereas in this case, you're doing that threefold dilution right on one plate. So that by the time you get to the outer rings of the spiral plate, you're at a dilution level where you can do counts, where it's not too numerous to count. So it's a really nice system, and again, all automated, so there's no manually inoculating the media itself. It's being done by the system. And that system is called the EdiJet. Again, a threefold dilution on the done by the system. This is also uses a patented disposable high accuracy micro syringe. Uses these micro syringe tips that avoid cross contamination and replaces wash cycles that have to be done because these are just thrown away. They aren't. There's no need to try and clean them or anything. So very dependable. It's been verified in multiple papers in comparison to the numbers that you get from a traditional or manual inoculation and dilution series. But again, you're achieving that dilution all in one at one time with this approach. So real quick, I wanted to show you another video. This is the EdiJet in action. So a very easy interface as far as being able to set up and run an inoculation. There you see the tips that are used to provide the inoculation. So fairly straightforward process. The key here, though, is that you're achieving that threefold dilution on one plate. So like you would have in 3 test tubes that then you have to transport to 3 petri dishes is all being done on one. And so you're eliminating all that the glassware that you have to use by doing this spiral plating on this one dish using this automated system. So you can see there how it works. Very straightforward, very fast. And again, the key to this whole process is these tips, because they're disposable and they don't have to be cleaned, it saves a huge amount of time. So you simply just keep a stock of those. You place them in the instrument. The instrument knows, can go and grab them, knows how much to dose based on how you program it. And so it's a real straightforward process. So here is how you load the tips. So they just basically set them in there. You get you one of the cups to place your inoculant in. Once you have the inoculant, you place it in the system, and then you start it. It goes and grabs a tip, loads it with inoculant, disperses it on the petri dish, and then when that's all done, the tip itself is simply discarded. So no bleach disinfection needed for cleaning up the system. You just simply discard those tips, and the next time that it runs an inoculation, it'll go get a new one. So that's all there is to it. It's a very nice process to give consistent results and eliminate any potential errors. Now, once you've done the inoculation, the remaining step after incubation and you have growth is to, of course, count the number of colonies that have grown because of that. And so the sphere flash is a great solution for being able to do colony counting, and the real advantage of this is that through automation you eliminate one of the primary ways of having mistakes in this whole process, and that is to try and correctly count the colonies and then transfer that information into a notebook and then into a LIMS system. This system can send that information, those counts, directly into a LIMS system, but it eliminates that requirement of doing a repetitive step again and again, where you start to see colonies that aren't actually there, and there's just really a lot of chance for problems because of that. This system is set up to eliminate problems that come from ambient light, makes it very accurate and repeatable. The data handling is Part 11 compliant. And when you start to look at just replacing the process of counting colonies manually, you're already at 6 hours a day in time savings for a normal number of dishes that you would go through. And so if you think about that in terms of ROI, you're basically at 10 months if you consider the labor costs that are eliminated, or at least optimized in being able to do other things by having this system. So real quick, we'll take a look at the colony counter in action. So what you'll see here is how easy it is to do a colony count. The chamber comes down, the image is captured, goes back up, the software takes it in. According to how you've set up the software, it does the counts and transfers those results. And the calculations are done based on any kind of dilutions that need to be factored in to give you an actual true colony count. And then the results in a CFR Part 11 protected way will allow that data to be automatically put into a LIMS system. So really, this is a critical part of the process. If everything else weren't automated, this one really needs to be automated just to eliminate the mistakes that can cause hours and hours of work to be lost when this step and this colony counting isn't done correctly. So a really critical tool for any kind of microbial testing laboratory. The results can be put out in several different formats, including a report, but again, can also be taken right into a LIMS system. And there's basically 3 different versions of the software, depending on what you want to do. There's a light version, a pro version that allows you to do color and size. And then there's also even a pro version that allows you to do zones of inhibition measurements and to produce an audit trail. So depending on what it is that you want to do, there's a software option that will provide that capability. But if you don't need the full version, then of course you can take one of the lighter versions instead. Just a real quick review of the return on investment So you can see an example here. We can assist with calculating this with an Excel sheet that we can share with you. Basically, you put in the number of dishes that per day and what the time it takes to do those and process those in a manual way versus what it does with the colony counter. You figure out a labor rate that to compare to, and then you can come up with an annual savings and compare that to what the automation cost is and come up with the return on investment. And so, to be able to do this correctly, we of course want to fine tune that to each individual situation. But again, we're willing to help and work with you on coming up with those types of numbers. So just real quick then, going back to the idea of a microbiology lab and the solutions that are being provided, we have everything, again, from media prep to an XY bottle filler to colony counting. We can provide automation for every step in the process that if you want, you can basically automate the entire microbial testing laboratory, all using Neutec equipment and all serviced by Neutec. So we have great service engineers that are able to take care of this equipment, the capability of being able to look at things remotely. So that's a really nice piece of this, is that you can outfit an entire and automate an entire microbiology lab through Neutec and have them as your sole source of service. And that can be really critical, as you well know, of having that continuity and that relationship. In addition, a few solutions that I didn't mention but are related. We do provide an air sampling system where if you need to do any kind of environmental sampling, we can provide a solution for that, and then the results of that can be taken directly to the colony counter. So the two in combination are a very effective way to create an environmental testing protocol and methodology. We also provide safety burners for Bunsen burner options. If you need those in a laboratory, we do have those, as well as the slide staining. If you need to stain slides for other stuff you're working on, we do provide a solution for that as well. And of course, we work with a lot of large companies. Some of the main producers in terms of food, cosmetics, and pharmaceuticals use this equipment and to automate their process and be able to increase efficiency while utilizing their labor force to its optimal effectiveness. So basically, we're here to help you get work done, whether that's, and especially even if you have any kind of potential interruptions in workforce, in supply chains. There's this a continual need for automation in everything that we do to be able to make it both more efficient, but also eliminate potential mistakes. And so it gives you confidence in your processing while leaving your labor force to do the most important tasks that they're truly uniquely, their unique skill set lends them to. And so we can provide all these solutions. We are always able to provide the newest technologies through our partners that we work with. We have great relationships, working relationships with our partners. So you can have worry-free confidence in our service that we can provide. We have, again, our service engineers are some of the best in being able to assist you. And of course, if you're interested in learning more about this, we can provide virtual demonstrations of the equipment. Are happy to do that. And we can also provide application support remotely, and we also have great preventative maintenance plans that we can both come on site or bring the equipment in as well.